A strange signal. A mysterious planet, orbiting a distant star. And a challenge to everything we thought we knew about life in the universe. This is Proxima B. Our nearest exoplanet neighbor, just over 4.24 light-years away, has captured the attention of scientists and dreamers alike. It's a place both familiar and alien, where hope and danger walk side by side. And now, thanks to the sharp eyes of the James Webb Space Telescope, a new chapter is unfolding, one that could reshape the search for life itself. Orbiting the red dwarf Proxima Centauri, this rocky world sits in the so-called habitable zone, but that term may be misleading. With JWST's powerful infrared sensors, we're finally seeing this planet with clarity like never before, and what's being revealed is both astonishing and unsettling. A planet in peril discovered back in 2013, Proxima B was long thought to be potentially Earth-like. But its orbit is incredibly tight, just 7.3 million kilometers from its host star, a mere fraction of Earth's distance from the Sun. 1 year there lasts only 11.2 Earth days. And its parent star? A small, dim red dwarf. But don't be fooled by its size. Proxima Centauri is volatile. It unleashes fierce solar flares, some hundreds of times more powerful than anything ever recorded from our Sun. These bursts of energy could, in theory, destroy a planet's atmosphere in mere minutes. What's worse? Proxima B is likely tidally locked, one side always facing the star, constantly bathed in light and heat, while the other remains in permanent darkness and cold. One side scorched, the other frozen. Is there any room for life in such extremes? Maybe. The twilight possibility. A growing number of researchers believe that hope lies in a narrow region between the two extremes, what's known as the Terminator Zone. This twilight belt, where day meets night, may offer a rare balance in temperature. In that fragile sliver, conditions could allow for one crucial ingredient: liquid water. Water, the cornerstone of life as we know it, might exist in this temperate band, if only just. Clues beneath the surface. JWST data also points to something else: the possible existence of subsurface oceans, much like those suspected beneath the ice shells of Jupiter's moon Europa or Saturn's Enceladus. These oceans, warmed by internal heat or tidal forces from the host star, could offer hidden sanctuaries for life, shielded from the violent flares above. There are even signs of a magnetic field on Proxima B. If real, it could act as a shield against solar radiation, preserving parts of the atmosphere and offering rare protection for surface or underground life. Some scientists speculate that the planet's atmosphere might collapse and recover in cycles, stripped during flare events, then slowly rebuilding. If true, any life here would need to be incredibly adaptable, evolving to survive the planet's harsh rhythm. A strange signal in 2020, a puzzling radio signal, was detected from the direction of Proxima Centauri. It was later explained as likely interference, but for a moment, it reignited global curiosity. What if we're not alone? What if Proxima B is more than rock and ice? A mission to find out. That's where Breakthrough Starshot comes in, a bold idea backed by big names like Stephen Hawking and Yuri Milner. The plan: launch thousands of tiny spacecraft, each the size of a microchip, to Proxima Centauri. Powered by Earth-based lasers, these the mission, a journey of curiosity and light. The task given to these microscopic travelers, no larger than a fingernail yet engineered with the genius of generations, is simple in words but extraordinary in meaning. Their purpose is to venture into the void between stars and return with something priceless: knowledge. They will attempt to capture the first close-up glimpses of Proxima B, an alien world that has long teased us from afar. Through their tiny lenses and miniature instruments, they will scan the planet's atmosphere, if one exists, measuring its thickness, its chemistry, its signs of warmth or erosion. They'll examine its magnetic field, its radiation levels, its potential for liquid water. And in doing so, they may unlock the most profound revelation of all, whether life, in any form, could ever survive there. These spacecraft may be tiny, but they carry with them the full weight of humanity's wonder. They are not just machines, they are ambassadors of our curiosity, silent messengers stitched from silicon and vision, racing through the eternal night at 1/5 the speed of light. Every bit they send back will be a whisper across time, a data-laced echo from the frontier of possibility. Beyond the mission, wisdom in emptiness. But what if, after all the effort and anticipation, Proxima B turns out to be lifeless? What if it is just a barren, irradiated rock, its surface seared by flares, its soil dry and silent, its skies empty? Even then, its importance would remain undiminished. Because space exploration has never been only about finding life, it's about understanding the boundaries of where life can exist, and pushing them further. Every observation, whether hopeful or grim, feeds into a growing map of cosmic conditions. It sharpens our instruments, challenges our theories, and helps scientists worldwide rethink how planets behave around stars different from our Sun. Each new planet we study is like opening a new chapter in an unwritten textbook of the universe, a textbook that we are writing as we read. And sometimes, it is in the silence of a world where nothing thrives that we find our most powerful insights. Proxima B, a symbol of the search. Proxima B is not just another planet catalogued in astronomical databases. It is a symbol. A nearby world that stirs distant thoughts. It invites us to imagine, to dream, and to ask questions we don't yet have answers for. It reminds us that the universe is not made of conclusions, it is built of questions. It is a canvas of mystery, stretched across distances so vast we measure them in years of light. And in this vastness, Proxima B is one of the first brushstrokes. It is a mirror, not just of our scientific progress but of our timeless desire to explore. It reflects our need to reach out, to make contact, to understand the fabric of reality beyond Earth. It is a proving ground for new technologies, a launch point for new ideas, and, perhaps, a cradle for something unexpected. The question at the heart of it all: beneath every mission, every theory, and every telescope aimed skyward, there lies a single, ancient question, one that has echoed through our species since we first looked up at the stars: are we alone? Is our planet the only oasis in an endless ocean of void? Or is it merely the first we've found, one of many scattered islands that dot the galactic sea? Maybe, just maybe, Proxima B will be the first place that offers us an answer. But that answer might not come as a voice or a signal. It may not arrive in words or symbols. It might come in subtler forms, in chemical fingerprints hidden in an atmosphere. In infrared warmth radiating from beneath an icy crust. In the rhythm of light that hints at a rotating world with something stirring beneath its surface. These may not be the sounds of speech. But they are signs, patterns, movements. They are not silence. They are not noise. They are a whisper. A whisper from far beyond our solar system. From a place that may be hostile,